This is the first 4.1b video. We are going to look at two important sampling techniques called a simple random sample and a cluster sample. And you'll be able to give the advantages and disadvantages of them. So a stratified random sample, it's when we put individuals in the population into similar groups, and these are called strata. Then we take a simple random sample from each stratum. A cluster sample is when we put the individuals into groups based on their location, and these are called clusters. Then we take a simple random sample of the clusters. So we get one cluster or however many clusters we need, and we use everyone in the cluster. So there are some important differences between a stratified and a cluster sample. Number one difference is in a stratified sample, the groups are similar within, but they're different between. For example, if we had a population of males and females, we put them in groups, males one group, females one group, the males are similar within the group, but there's a big difference between males and the females group. Clusters are a little different. Clusters are heterogeneous groups, so they are mixed within. We want the clusters to look like the population, so there would be males and females in each cluster. The second thing is the cluster sample, we randomly select and use the entire cluster. For the stratified sample, we randomly select a certain number of people from each stratum. So let's do a simple example to get a better understanding of the difference. So let's suppose that shapes have opinions. We wanted to know which sport is the favorite among the population of shapes below. Since the population is so large, not really, and we don't have time to ask every shape, we're going to take a sample of 4 and ask each shape which of the following sports is your favorite: basketball, soccer, cricket, or basketball. So here's our population, and we want to take a sample size of 4. So let's refresh on what a simple random sample is. Simple random sample, we're going to number every shape in the population, and we're going to randomly generate 4 numbers, and that's going to be our sample size. So I'm going to go ahead and number these now. Now that I've numbered the individuals in the population, I'll open up my calculator and generate a random number between 1 and 16. So to generate a random number between 1 and 16, I'm going to do math, probability, go to rand int. Lowest number is 1, comma, largest number is 16. So I get number 16, number 15, number 3, and number 9. So I'll copy those over to my paper. 16, 15, 3, and 9. Okay, so I've copied over what I used in my calculator, and just a reminder, this is a simple random sample, or an SRS. And so my individuals, or shapes in this case, in the sample are going to be the shapes that correlate or correspond to these numbers. So I will include shape number 16, which is this circle, 15, which is this triangle, 3, which is this star, and 9, which is this star. So you might realize that I've got an issue here. I'm not including, what am I missing? I'm missing a square. I don't have a square included in my sample. So really this isn't perfectly representative of the entire population because everyone is not represented. So to fix this problem, we can do what's called a stratified random sample. So for my stratified random sample, I've reset the population back to the original. I'm going to break these, I'm going to break up my individuals into similar groups. So I'm going to have a group or strata of circles, squares, triangles, and stars. So I'll go do that now. So now that I've broken the population up into the 4 different strata, I'm going to number each individual in the first strata and randomly select 1 because I need 4 total. So I'll have 1 from each strata. So on my calculator for the first square strata, I entered my random integers from between 1 and 4, and I received number 2. So the second one, this is the first shape in my random sample. I'm going to repeat the same process for the next 3 strata and randomly select 1 of them. So you can see I've randomly generated numbers between 1 and 4 for each of them. I got the first of the circles, the second of the stars, and the third of the triangles. So the benefit from this versus the simple random sample is now I have 1 from each different type of shape included in my sample. And I want my sample to be representative of the entire population. Since there are an equal number of squares, circles, stars, and triangles in the population, I would like to have an equal number of the same shapes in the sample. So that is one benefit for using a stratified sample. You just have to remember the groups are the same within, but different between. Circles and squares are different. Circles and stars are different, as well as with triangles. So I'm going to reset my population back to normal and walk through a cluster sample. Okay, I've reset the population, and I want to walk through how to do a cluster sample here. So a cluster is when we put them in groups or clusters based on their location. And we want the cluster, each cluster, to be representative of the entire population. So we don't want them to be full of just squares. We'd like them to have 1 of each if possible. So if we're doing it based on location here, I'm going to break them up either in groups based on their column or based on their row. And the benefit here is if I do it by column, then if you look here, I'm going to have a square and a square, and I'm going to be excluding triangles. If I go by column for this cluster, it's going to be 2 circles and missing a square. So the best way to do it for this population would be based on the row. Because if you look at each row has a circle, triangle, diamond, or a star, and a square. So I'm going to number my clusters here. And so with a cluster sample, I'm going to randomly generate 1 number between 1 and 4, and I'm going to use every shape in that cluster. Now, if I wanted a sample size of 8, then I would randomly select 2 clusters, but in this case, I just want a sample size of 4. So on my calculator, I randomly generated a number between 1 and 4, and 2 was that random number, so I'm going to select every shape in my second cluster, and that is going to be my sample of shapes to figure out what their favorite sport is. So the key here is that when you're working with a cluster sample, a lot of the reason you work with a cluster sample is because it's easier to put them in groups based on location. But stratified, if it's easy to put them in similar or homogeneous groups, then you can go ahead and do a stratified sample. Let's scroll down and take a look and see a more real world type scenario. So here we have an auditorium for a school assembly, and the student council wants to conduct a survey about the use of the school library during the first 5 minutes of an all-school assembly. There are 800 students present at the assembly. Here's a map of the auditorium. Note that students are seated by grade level and that the seats are numbered from 1 to 800. So they're using this assembly to figure out the use of the school library. And 9th graders are seated in the back from 601 to 800, and 12th graders are seated in the front from seats 1 to 200. So what we want to do is describe how to obtain a sample of 80 students using a stratified random sample. Explain your choice of strata and why this method might be preferred to a simple random sample. So first, if we're doing a stratified sample, we need to figure out what are our strata going to be. And strata should be similar within, but different between the groups. And it's easy if you think about it. Are freshmen going to use the library as often as the seniors are going to use the library? It's more likely that seniors are going to be in the library more often because they have more research projects. So since there could be a difference based on the grade, then we want to make sure we have an equal representation of freshmen, sophomores, juniors, and seniors. So I'm going to break them up into strata based on their grade. And the way I can do that is they're already in their seats based on their grade. So I'm going to randomly generate, if I want a sample of 80 students, then I'm going to take 20 from each class. So I'm going to randomly generate a number between 1 and 200. I'm going to randomly generate 20 numbers between 1 and 200. And those students sitting in those randomly selected 20 seats are going to be given the survey. Then I'm going to repeat the same process for the 10th, 11th, and 9th grade students. So I'm just going to be using my calculator and do randint from 1 to 200 and select 20 random numbers, and those students will be included in my sample. So I'm going to go ahead and write out how I'm going to do this, and then I'll discuss the benefits. So again, I'm going to put them in strata based on their grade levels because it will be similar the amount of time freshmen use in the library, but it will be different between the freshmen, juniors, seniors, and sophomores. So since there is that difference between the groups, those will be the best selection of strata. And I'm going to generate 20 numbers between 601 and 800 for the freshmen because that's where their seats are. I will give them the survey, and the stratified sample, if I stratify by grade, it should give me a more precise estimate for the total population, which is the entire school. Because if I did a simple random sample, there's potential that I could end up with only freshmen and seniors, or I could only end up with juniors and sophomores. If I've got strata, I'm guaranteed to have an equal representation of each class. Let's finally take a look at how to obtain a sample of 80 students using a cluster sample, and we'll discuss why this might be preferred to a simple random sample. So if I want to take a cluster sample, then in each cluster I need to have freshmen, sophomores, juniors, and seniors. And instead of taking a simple random sample from each group, I'm going to randomly select and use everyone in my clusters. So based on the seating, if I put them in groups based on their row, then row 1 is going to have freshmen, sophomores, juniors, and seniors all present. So I'm going to break them up into groups, into clusters based on their row. And if there are 20 rows and there are 800 students, that means they're going to be 40 in each row. So I'm going to need to randomly select 2 of these rows to get my sample size of 80. So I'm going to number, and they already are, 1, 2, all the way up to 20 for each row. I'm going to randomly generate 2 numbers, and I'm going to use every student in that row or in both of those rows as my sample. So I'll go ahead and write this process out and then talk about the benefits of it. So as you can see, this is everything that I just said earlier. And the biggest benefit is the ease of collecting the sample. The cluster sample is more efficient than finding 80 random seats that are scattered throughout the auditorium. So this might be preferred to the simple random sample as well as the stratified sample, because I can just hand out the papers to 2 rows and it'll be easy for them to pass them back. So with this in mind, the difference between a stratified and a cluster sample, go ahead and see how you do on these independent practice problems on the next page.